Welcome back. Let's now have a similar problem to the car towing one, but now we are in the water. We have two tugboats carrying cargo on the water. So this boat C, that's the cargo boat, and then boat A and B, they are two tugboats. And so the information that you're given now is the following. This red vector, that's your FA, and that's 2000 newtons. And its direction from the positive x-axis is 30 degrees. So this is boat C, this is boat A, this is boat B, this is vector FA, which is 2000 newtons, and the angle here is 30 degrees. The unknown quantities are FB, then angle theta, and the resultant vector FR. And 30 degrees here is, of course, counterclockwise. We define that this is the positive x-axis and this is positive y-axis. So the cargo boat, it needs to move along the positive x-axis. And it is not important how much force is directed along the positive x direction due to these two tugboats. What is important though is that FB needs to be as small as possible. So you should minimize FB. And so your task is to find FB, theta, and FR so that FR would point in the positive x direction and so that FB would be minimum. So what would be FR, theta, and FB if your job is to minimize FB and the boat needs to move in the positive x direction? Again, try it out yourself first, and then I'll show you how I did it. Good luck. Welcome back. So let's now solve this boat exercise. You have to find FB, theta, and FR such that FR points in the positive x direction and FB is minimum. You know that FA is 2000 newtons, and you also know that it's 30 degrees counterclockwise. You don't care about the magnitude of FR. You only care that its direction is in the positive x direction. Let me again draw this x and y coordinate frame here that measures forces. So this is FA, and now using the triangle rule, you can get your FR by adding FB to FA in multiple ways. I can do it like this. This could be my FB, or this could be my FB, or this could be my FB. In all these cases, I will get a resultant vector FR that is along the positive x-axis. But when is FB minimum? Well, you can see that it's minimum when it's vertical, when FB is like this. When FB is like this, then its vector magnitude is greater than this vertical version. Similarly, when FB is like this, then this vector magnitude is greater than this vertical version. So this FB is minimum when it points vertically down. And then this one, it would be your FR, your resultant vector. And what does that mean for theta? Well, remember this FB is just a shifted version of this one here. And so that means that this theta here, well, it's 90 degrees, right? So we have one unknown. Theta equals 90 degrees. And now, knowing the direction of FB, which is 90 degrees clockwise, we can find out what the magnitude of FB is and what FR is. Again, I'm going to take this FA vector and I'm going to shift it here. You know that this here, it's 30 degrees. And so here you have 90 degrees. And so essentially what you have a right triangle here, where here you have 30 degrees. FB can be calculated very easily using the sine law. First of all, you have FA over sine 90 degrees, which equals FB over sine 30 degrees. Remember that this FA is 2000 newtons. And so FB equals 2000 times sine 30 degrees divided by sine 90 degrees. Sine 30 degrees equals 0.5, sine 90 degrees equals 1, and that means that FB equals 1000 newtons. And now you can use Pythagoras theorem to calculate FR. You have FR squared plus FB squared, which is 1000 squared, and that equals FA squared, which is 2000 squared. So FR squared equals 2000 squared minus 1000 squared, and then I'm going to put it to the power of 1/2. Then I will get rid of this 2 here, and so FR equals more or less 1732 newtons. And there you go, you have your theta, you have your FB, and your FR, and both of your conditions are met. Your FB is minimum, and your FR points in the positive x direction. Here in this Python animation, you can also see that your FA is 2000 newtons, and then your theta angle, that's 90 degrees, and so your FB, which is the minimum, is 1000 newtons, and your resultant vector is 1732 newtons along the positive x direction. Here in orange you can see alternative FB vectors. You can see that in all other cases it's longer than this minimum case. So in whatever other direction it goes, the magnitude of FB is always longer than this minimum case here. So that's why theta needs to be 90 degrees. Thank you very much. Welcome back. So we have just solved an exercise where we had to find FB, theta, and FR so that FB would be minimum, and the information that we had was that FA was 2000 newtons and then at 30 degrees counterclockwise. And we found that in order to make sure that both C goes in the positive x direction, and so that FB would be minimum, theta had to be at 90 degrees clockwise. You had to have this kind of situation. But now let's change the initial conditions a little bit. The environment is the same. You have this cargo boat C and 2 tugboats A and B. Again, you have a force vector FA at plus 30 degrees or 30 degrees counterclockwise, and then you have force FB, and here you have your angle theta, but now you don't know what the magnitude of FA is. But what you do know is that the resultant force vector from these two vectors still needs to point in the positive x direction, and now this resultant vector needs to be 10,000 newtons. So you don't know your theta, you don't know your FA, you don't know your FB, but you know that FR needs to be 10,000 newtons. And now the question is, what is FA, what is FB, and what is theta if you know that FR needs to be 10,000 newtons in the positive x direction and FB needs to be minimum? So try to figure this one out by yourself first, and then I'll see you in the next video where we will discuss it. Thank you very much. Welcome back. So now let's try to solve this exercise where you know that your resultant vector needs to be 10,000 newtons, but you don't know your FA, nor FB, nor theta. And so another condition is that your FB needed to be minimum. So let's try to solve this problem now. Let's see if we can figure this out. Your first reaction could be using the same technique that we used in the previous problem. So your FR is now fixed. It's 10,000 newtons. And you know that this angle here is 30 degrees. So maybe I can construct this right triangle here, where this is my FA, this is 30 degrees, and then again, theta would be 90 degrees. In that case, FB would point down like this. And you might think that this FB is the minimum. But is it really the minimum? Now we have different conditions. In the previous case, we knew our FA, and we didn't care how big FR was. But now, FR is fixed, but FA can vary. Now obviously, if I made this FA even longer like this, and then I would make FB like this, then obviously this vertical version would be smaller. But what if I make my FA smaller? What if instead of this version, I will have this version? Maybe it helps if I treat this green arrow, 10,000 newtons, as a hypotenuse in a right triangle. So I'm gonna flip this triangle upside down. In the first case, FA is like this, then this would be FB, and this would be my FR. That's the case where I treat FA as my hypotenuse, right? You can see that you have your right triangle here. Right now, I don't consider this case, nor this case. I'm following the technique that I used in the previous case. So you have a right triangle here, but if I turn it upside down, then it looks like this. You have 90 degrees here, which means that you have 90 degrees here as well. But how about I do it differently? How about I start decreasing my FA? And instead of treating this one as hypotenuse, I treat this one as hypotenuse. In that case, this would be your FA, and this would be your FB. And here you would have 90 degrees. And you would agree that this FB, which is vertical, is smaller than the other FB. In fact, you can see visually that that's the case where FB is minimum. If I make FA even smaller, then FB becomes bigger than the vertical case. And then if I make FA greater, then also FB here is bigger than the vertical case. So really, if your objective is to minimize FB, then this seems to be the best case. And if you turn this right triangle upside down again and put it in this form, then this 90 degrees here, well, it would be here. And so the methodology that we used last time, it's not correct anymore. It will not give you the smallest FB possible. Instead, it's this one. So I take this FB vector and I shift it here, and then here I have 90 degrees. But then if I choose this configuration, then what's my theta? Well, if I take this FA and I shift it here, and again, here you have 90 degrees, then since they are the same triangles, since you have 30 degrees here, you also have 30 degrees here. So this is 30 degrees, and this is 90 degrees. So theta equals 180 minus 90 minus 30 degrees, which is 60 degrees. So when theta is 60 degrees, then you obtain your minimum FB. And now, in order to find FA and FB, in order to find their magnitudes, again, you can use the sine law. You have 10,000 newtons, the green one, divided by sine 90 degrees, this one, equals FA, this one, divided by sine 60 degrees, 60 degrees is theta, equals FB, which is this one, divided by sine 30 degrees, which is this one. You already know that sine 90 degrees is 1, and so FA equals 10,000 times sine 60 degrees, that's more or less 8660 newtons. And then FB, well, this is 10,000 times sine 30 degrees. Sine 30 degrees is 0.5, so you have 5,000 newtons for your FB, which is minimum. So now you have seen two versions, and what is the conclusion that we can draw? In these kind of problems, the conclusion that we can draw is that the vector magnitude that is given, treat that as a hypotenuse in a right triangle in order to get your minimum FB. In the first case, you didn't care about your FR. You had your FA and you had to minimize FB. And so what you did, you treated your FA as a hypotenuse because FB and FR, they could vary. But the vector magnitude that was fixed, you treated that as a hypotenuse. And then here you had your 90 degrees and you obtained your FB minimum. That was the previous case. In this case, however, the fixed value was FR, not FA. And since FR was the fixed value, you should treat that as hypotenuse. So now this is fixed value, 10,000 newtons, and this should be your hypotenuse, which means that this is your FA that can vary, and this is your FB that can vary, and you have to form a right triangle here. And if you do that, then you will have a minimum FB value. That's because you take the fixed value and you treat that as a hypotenuse. And so here from Python animations you can see that first of all FR equals 10,000 newtons, and I experimented this thing with theta equals 90 degrees like we did in the previous case, and you can see that your FB is 5,774 newtons. But then when theta equals 60 degrees, then your FB becomes 5,000 newtons, and your FR is still 10,000 newtons. So your minimum FB value is 5,000 newtons. And now, if I slightly lower my theta and I make it 59 degrees, then you can see that FB is slightly larger, 5,001 newtons. And then, if I make theta slightly larger than 60 degrees, so 61 degrees, then again, while my FR is 10,000 newtons, my FB is slightly larger, it's 5,001 newtons. So only at theta equals 60 degrees, I have the minimum FB value, which is 5,000 newtons. And there you go. This is how you solve these kind of exercises, and that's how you add vectors using the triangle or the parallelogram rule by utilizing the triangle properties like the sine rule or the cosine rule. Thank you very much.